Welcome students, we've been given this question: x squared positive y squared positive z squared is equal to 64, a squared positive b squared positive c squared is equal to 49, ax positive by positive cz is equal to 56. We are expected to evaluate a positive b positive c divided by x positive y positive z. So we need to obtain the solution for this, or the value for this. I can just take this as 1, 2 and 3. Now I will first consider equation 1. So I'm just going to state that consider 1. So this is x squared positive y squared positive z squared is equal to 64. Now there are a few observations you will have to make. Now you can see here, this is 8 squared, this is 7 squared, and 8 multiplied by 7 is equal to 56. So these are some of the observations that would help you to solve this question. So you are trying to convert this entire system into a perfect square. So how are we going to achieve that is this objective of this particular working. So having considered 1, what I would do is I would be dividing both sides by 64. So this is going to be divided by 64. This is going to be divided by 64. So this can be rewritten as x squared over 64 positive y squared over 64 positive z squared over 64 is equal to 1. Now I can rewrite this further as x over 8 raised to the power of 2 positive y over 8 raised to the power of 2 positive z over 8 raised to the power of 2 is equal to 1. Now let me name this as equation 4. Now I would be considering equation 6, not 6, I should say consider 2 now. So this is a squared positive b squared positive c squared is equal to 49. So I would like to divide both sides by 49. So this is going to be divided by 49. This is going to be divided by 49. I can rewrite the left side as a squared over 49 positive b squared over 49 positive c squared over 49 is equal to 1. I can further rewrite this as a over 7 raised to the power of 2 b over 7 raised to the power of 2 positive c over 7 raised to the power of 2 is equal to 1. I'm going to name it as 5. Now let me consider 3. Consider 3. So this is ax positive by positive cz is equal to 56. So let me divide by 56 both sides, and I wish to rewrite this as a over 7 times x over 8. Right? Fair enough. 7 times 8 is 56. In fact, let me place in one more step. Let me write this as ax over 56 positive by over 56 positive cz over 56 is equal to 1, and then I will split it up as 7 and 8. So a over 7 times x over 8 positive b over 7 times y over 8 positive c over 7 times z over 8 is equal to 1. So that looks nice. So I have to rename it, or else I should say I have to name this system as 6. So I have to use 4, 5 and 6 so that I'm in a position to have something that would contribute in obtaining the value for this expression a positive b positive c divided by x positive y positive z. So let's do that. So what I'm going to do is I'm going to add 4 with 5 and then subtract 2 times of 6. So this is going to be our plan of action. So let us do that. 4 with 5. So x positive 8 raised to the power of 8. Now when I'm adding, I'm going to adopt this particular way of adding. You see here, I'm going to take the first quantity with the first quantity and then minus 2 times this quantity. So it's going to be like this so that you can follow. So the first quantity added with the first quantity of the equation 5, then I subtract 2 times of this quantity. Okay, now when I do that, this is on the left side, right? On the right hand side we will have a term. I'm going to place that term within a minute. So we will have to take into consideration the right hand side also. Right hand side is 1, 1 and 1. So we will work it out. This is my plan of action. First quantity plus first quantity followed by negative 2 times the quantity that you see here for equation 6. So x positive 8 raised to the power of 2 followed by a over 7 raised to the power of 2 negative 2 times of a. I have written it as a over 7, so I'm going to place it as a over 7 times x over 8. So it doesn't matter whether 7 comes here or 7 comes here. So this is one quantity. Okay, so let me put it in a box. Okay, followed by, I'm going to follow it up with the second quantity added up with the second quantity minus 2 times this quantity. So let me do that. So that's going to be y over 8 raised to the power of 2 positive b over 7 raised to the power of 2 followed by negative 2 times b over 7 times y over 8. Okay, that's the quantity there, and followed by this quantity added up with this quantity subtracted by this quantity. Okay, so let's do that. Z over 8 whole squared positive c over 7 whole squared negative 2 times z over 8, so it's going to be c over 7 wholes times z over 8. That's fine. So this is left hand side. The right hand side is going to be, let me show you, this quantity added up with this quantity minus 2 times of this quantity. So it's going to be 1 plus 1 minus 2 times of this quantity. So this is equal to 1 plus 1 2 minus 2. So this is going to be 0. Now just concentrate on the first term. What is this? X over 8 whole squared positive a over 7 whole squared negative 2 times a over 7 times x over 8. So can I write this as x over 8 followed by negative a over 7 raised to the power of 2. Can I do that? Now if I were to use, I'm actually using a negative b whole squared formula, which is a squared positive b squared negative 2 times ab. If I were to expand this, I would get x over 8 whole squared, the first term, followed by a over 7, the second term, whole squared, and 2 times ab. So in this case I have written it as 2 times a over 7 times x over 8. So can I write it like this? Of course yes. So this is going to be followed by the second term, so y over 8 negative b over 7 and I raise it to the power of 2. So y over 8 squared plus b over 7 squared negative 2 times b over 7 times y over 8, b over 7 times y over 8. So that's perfectly fine, followed by the final quantity. So this is z. Okay, so this is going to be z over 8, right, negative c over 7, and that is raised to the power of 2. Z over 8, when you square it you get z over 8 squared, followed by, when you square this term you get this term c over 7 whole squared, followed by negative 2 times c over 7 times z over 8. So you get this term. So apparently it seems that we are in a position to rewrite all this expression in a perfect square fashion. Now coming to the right hand side, so 2 negative 2, what is this? This is equal to 0. So now let me rewrite this again. So what have I got? I've got x negative 8 negative a over 7, this is squared up, followed by y over 8 negative b over 7 raised to the power of 2, followed by z over 8 negative c over 7 raised to the power of 2 is equal to 0. Now this square plus this square plus this square gives me equal to 0. So what is the observation that you see here? You see a sum of squares being equal to 0. When would this be possible? This is only possible when x over 8 negative a over 7 is equal to 0, when y over 8 negative b over 7 is equal to 0, when z over 8 negative c over 7 is equal to 0. So this is when this is possible. So having obtained this, what I wish to do is I wish to rewrite this, the first term, as say x over 8 is equal to a over 7. So I can replace now x as, I'm going to rewrite x to be as a over 7 times 8. Now similarly I can rewrite y to be as b over 7 times 8, and then I can rewrite z to be as c over 7 times 8. So this is the representation I've got. Now we are asked to find what is a positive b positive c divided by x positive y positive z. Now a positive b positive c, I'm just retaining it as it is. In place of x, y, z, I'm going to substitute. This is 8 over 7 times a, 8 over 7 times b, 8 over 7 times c. Now let me use this space over here. Okay, so this is a positive b positive c divided by, now 8 over 7, 8 over 7, 8 over 7 can be taken out, and then we got a positive b positive c. Now I can cancel a positive b positive c with a positive b positive c, so I get 1 over 8 over 7. When I flip it, I get 7 over 8. So this is the solution to this question, students. Thank you.